So before we move on, remember from last time that I said the quotient rule is one way to take the derivative of this function, and there's also another way, which we first use the product rule, and then we use something called the chain rule. So in this video, I am going to use this question to explain the chain rule, and also hopefully we're going to prove it. So first of all, the chain rule states that if we have again a f of x and a g of x, then the derivative of f of g of x, which we use this notation to express, is equal to f prime of g of x times g prime of x. Okay, and before we implement the rule on our original function, let's also just make sure we prove it. Let's use the right side of the board. This line is kind of wiggly. Perfect. So let's start our proof. Again, we start with the definition of derivatives. So by the definition of derivatives, the derivative of f of g of x is equal to limit as h approaches 0 of f of g of x plus h, bracket here, minus f of g of x over h. Now we're going to use a very subtle way of proof here, which is we are going to let u equal to g of x. Okay, so what that means is if we have a du, then our du is going to be g of x plus h minus g of x. Because again, h is approaching 0, that means this function g of x plus h is so close to g of x, and therefore it's our du we want to find. So what that means is that g of x plus h is going to equal du plus g of x. And because g of x is equal to u, that means our g of x is equal to du plus u. Okay? And so let's substitute our du plus u into our original limit. So what we get is limit as h approaches 0 of f of u plus du minus f of g of x over h. And now remember that g of x is equal to u, so don't forget to also substitute the g of x into u. Okay, so here is u. Now we can further simplify this expression a bit by multiplicating this whole function by du over du. So why is that? We want to do this because we notice that we have a numerator like this, and notice that this really looks like the definition of derivatives, and therefore to finish this we need something similar to du, or in other words we need du. So therefore we are going to give you a du on the denominator, but to make the limit equal, so don't change the limit, essentially we need to again, times a du on the numerator. So that gives us, let's change this limit slightly. So that gives us f of u plus du minus f of u over du times, so this is basically a du over h, okay? Now we know that this is equal to f prime of g of x, because now we know that u is equal to g of x. This is essentially just f prime of u. And because of u is equal to g of x, this is equal to f prime of g of x, okay? So therefore, this is going to be f prime of g of x times limit as h approaches 0 of du over h. Now, we know that du is equal to, from here, g of x plus h minus g of x. Therefore, we can also substitute this in. And what we get is, on the numerator, g of x plus h minus g of x. And here we get something really familiar, which is again the definition of derivatives, and this is g prime of x. And so therefore, we get our answer f prime of g of x times g prime of x. And thus we have proven the chain rule is whatsoever a really subtle but yet simple proof. So getting back to our function, we are going to basically utilize the rule we just proved and see if we get the same answer as last time. So let me write it right here. Okay. By the proof, or by the rule, by the chain rule, we know that f prime of x is going to be equal to, let's say f of x is going to be equal to sine of x times e to the negative x powered, and f prime of x is going to equal to, first, we're going to use the product rule. So the derivative of sine of x is equal to cosine of x times e to the negative x. We don't change this. Then plus, so now what's the derivative of e to the negative x powered? So first of all, we don't change e to the negative x powered. Then we are going to times or multiplicate negative 1 again by the chain rule. Okay, so therefore we have negative 1 times e to the negative x powered times sine of x. So let's simplify this a bit. So basically this is, we have e to the x, on top we have cosine of x minus sine of x. Now remember from last time we have e to the x powered times cosine x minus sine of x, and on the bottom we have e to the 2x powered. So essentially these two equations, or these two expressions, are the same, and thus we have first proven the chain rule, and also I've simply demonstrated that the chain rule plus the product rule is possible for this question, to differentiate this question. So I hope you enjoyed today's video, and I'll hopefully see you in the next video.